All right, so we're going to talk about combining two different things. We're going to use absolute value and we're going to use inequalities. So let's see what that would look like so that you can start to become familiar with this. So we're going to have a problem 4x minus 8 minus 5 is less than 11. So just like we were doing yesterday, we're going to go ahead and add 5 to both sides. We're trying to isolate that inequalities or the absolute value so that this absolute value, the stuff that's in the bars, is all by itself. So here we go. We have 4x minus 8 in the absolute value bars is less than 16. Okay, so we're going to do the same thing. We have two cases. We have the positive case, which is going to be 4x minus 8 is less than 16. And we're going to have the negative case, which is 4x minus 8. Okay, but it's the negative of this. Okay, we're pretending that this is negative. Okay, now you have two choices here. You can either do it like I did here, okay, or you can set it up like this. Okay. Last time when we were doing this, we set the thing that it equals to negative, okay? But if you do that, you have to change the sign. Okay, remember when we divide or multiply by negative numbers, there's this whole sign change that happens. We flip it around, okay? We flip around the less than or greater than. And so we're going to do that here. And you can either do it like this, or you can do it like this. And I don't care which method you use. Your textbook uses this method, okay? So I think for now, that's what I'm going to use, but just know that one way is, there's not one way. There are more than one way. So I'm going to write that a little bit higher just so that we have a little bit more room for the math. All right, so let's go ahead and start solving. So we have over here, we have plus 8. So 16 plus 8 is 24. And we are going to divide by 4. So we have x is less than 6. Over on this side, we're going to add 8. And so we have negative 8. And we're going to divide by 4. We have x is greater than negative 2. Okay. Now we have to check them, right? So actually, do we have to check them with this? I don't know that we do. We can just draw a number line. So let's do that. Let's do it with the red one. So here's my number line. I have a negative 2, negative 1, 0, 1, 2, 3, 4. Should have made my number line bigger. See, 1, 2, 3, 4, 5, 6. Okay, and so let's go ahead and highlight what our answers are. Our answer could be less than 6, that's going this way, or our answer could be greater than negative 2. So it's actually going to be this portion here in the middle. We have open circles because it's not less than or equal, it's just less than. We have that. So that is how you do that. And we kind of shade it in between or highlight whatever works for you to make that easier to see. So that's what we're doing when we have it like this. Let's see a few more examples just to make sure that you've got it. And again, you can back up if you need to. Pause as I'm talking. Whatever works for you is good with me. So let's do this example as a little fraction, which always makes us nervous, but I believe in you. So we have this absolute value bar over a fraction plus 5 greater than or equal to 14. So let's go ahead and solve for that absolute value. 14 minus 5 is 9. And we still have the 6x plus 3 over 2. Let's multiply by 2 on both sides. So we have 6x minus 3 greater than or equal to 18. So now we're going to do our two cases. So we have one case over here that's our positive case. I don't know why I keep drawing the absolute value bars. We don't need them anymore. So 6x minus 3 is greater than 18. sorry, greater than or equal. And then over this side, we have our negative case. So we have our 6x minus 3. Okay. And again, we flip the sign, minus 18. Yeah. Okay, because we're making this a negative. So we flip the sign and we change it to a negative. All right, so let's start. So plus 3 on both sides. This is 21. Okay, x, we're dividing by 6. So we have x is greater than or equal to 21 over 6. You know what? That can be reduced, my friends. We're going to divide by 3 on the top and the bottom. 21 divided by 3 is 7. 6 divided by 3 is 2. So x is greater than or equal to 7 over 2, which, by the way, I'm checking something. I wrote something wrong, didn't I? Look, when I wrote my problem here, I wrote minus. These should be pluses. So you're going to have to ignore the things that I said just a minute ago, and we're going to fix it. Okay, so we have to subtract by 3 instead. I made a mistake. See, this is why when I make videos and you aren't here to catch my mistakes, sometimes we just are going to have them. But that's okay. We're still going to do the same thing. And so we have x is greater than or equal to 15 over 6. 15 over 6 can also be reduced, so divide by 3 on both. This is 5 over 2. Okay, we could also say that if we wanted to as, what is that? 5 divided by 2 is 2.5. So if you want the fraction, you can keep the fraction. If you want the decimal, keep the decimal. I kind of like the decimal because we're going to put it on a number line, and so that'll make it a little easier for us to handle. Okay, so on the negative side over here, we're going to do the same thing. We're going to end up with some similar numbers to the first time because of the way this math works. So we have x is less than or equal to 21 over 6. So again, we're reducing that fraction by dividing by 3 over 3. So this is 7 over 2. Okay, 7 over 2 is 3.5. Okay, but this is a negative, so we want to make sure we keep that negative. That negative is not obvious. Let me scooch this over. 3.5, so negative 3.5. That'll be easier to read. So we have a number line. We have negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Okay, and then when we draw this, we have x is greater than or equal to 2.5. So close circle over here on the 2.5. And it continues over this way. So this is actually disjointed. That means it doesn't actually connect. We have the less than the 3.5. So that's over here, closed circle. Okay, and so that comes this way. So that's what we have. If we were to write this in set notation, it would look like x such that x is less than or equal to negative 3.5, or x is greater than 2.5. Sorry, greater than or equal to. So you can write it in either way. I'll take both. Let's see what our next example is. I think the next example I'm not going to have everybody do. So I'm going to go ahead and stop this video. Good luck.